over ice cream in the park, but I'm sure ice cream in the park can come later. So thank you so much for joining us this evening. My name's Alyssa Gilbert. I'm the Director of Innovation at the Grantham Institute for Climate Change and the Environment here, and the co-director of, one of the co-directors of our new School of Sustainability. Before I start, just a quick, this is even before housekeeping. There was just a bit of an event earlier that some of you may have been at where some startups pitched, and one of the startups had some brown paper bags on their stand. They may have been tempting, but they weren't freebies. So if anyone picked up one brown paper bag, it's like an important part of their business. So if you can just go and put it back before you go, that would be great. Otherwise, you may not be in this room, and it's not, you know, accusing anyone of anything. So if you could please do that, that would be great. Okay, so thank you for joining us. Hopefully you think that you are here for the launch of the briefing paper on microbial food as a sustainable, healthy, and resilient source of nutrients in the UK. That's what we're here for. Before we start, just a few housekeeping things. The session is being recorded and streamed live. Please be aware of that. That means that if you ask a question, it will be recorded. If you are asking a question later, please wait till the microphone reaches you, because that means that the people online can also hear the question that you're asking. So we would appreciate you. I'm sure you'll be very eager to ask your question, but just wait until you get the microphone. And then the final thing is we're not expecting any kind of fire alarms, nothing planned. So if you do hear it, please just follow the emergency exits. Online attendees, I don't know why I should be looking to you there. Online attendees, if you have a question, put it in the Q&A. The people with the microphones have been instructed to occasionally give you the floor as well. So there'll be opportunity for you to participate. Okay, so to the paper. The paper is a collaboration of many disciplines across Imperial. And it's an attempt to try and bring together what these kinds of foods, microbial foods, have to offer us in terms of improved health, in terms of improved kind of environmental and climate change impacts, and food security as well. So what we're going to do is the main author of the paper, and also the lead of the Bezos Center for Alternative Proteins. I'm standing in front of a sign, the Bezos Center for Sustainable Proteins. Dr. Rodrigo Ledesma Amaro is going to take us through the main points of the paper first, and then we've got some guests from outside the university and inside the university who are going to join us on a panel to discuss what the paper says and allow you to ask questions to dive more into depth on some of those issues. So without further ado, Rodrigo, the floor is yours.
Hi, everyone. I'm going to give you a very brief overview, but you still need to read the report by yourself. So the report says microbial food as a sustainable, healthy, and resilient source of nutrients for the UK. And it's divided in three main sections: a set of the scene, and then a series of policy recommendations. And I'm divided my presentation as well in the same areas, so we can cover a little bit an overview of everything. So I would start by section 1, which is why do we even need to be here talking about microbial food? And this is because our food system has many, many challenges. One of them is sustainability. Our food system contributes to 1/3 of the greenhouse gas emissions worldwide. This in the UK is around 1% of the greenhouse gas emissions come from agriculture, and that's equivalent to 48 megatons of CO2 equivalents. Our food system also takes a lot of land. In the UK, 67% of the land is used for making food and feed. Out of that, 85% of the crops are used for animal feeding, not for human food. And there's some side issues with soil biodiversity loss and habitat loss with that land use as well. On top of that, 30% of the food that is made worldwide is wasted. And you don't need to go too far to see this. It's happened here in London and here at Imperial. The second challenge is about health and nutrition. We are moving towards diets that are not the best. So the last report from the National Diet and Nutrition Survey says that we are consuming 30% more saturated fats than we should. We are consuming only 66% of the fibers we will need, so we need to eat more fibers. And the deficiencies in the UK in iron, zinc, vitamin A, D, and calcium are increasing. The population is growing in the world, and that's another reason why we need to make foods in a different way. We cannot continue doing the foods in the way we do because there's not enough land, not enough space and resources to do that. But in the case of the UK, even if we are not growing that much, there's problems of insecurity, and 42% of the food that we consume come from abroad, and 45% of the animal feed or the food we use for our animals is produced outside the UK. The fourth challenge is about affordability. So worldwide, 2.8 billion people cannot afford a healthy diet. And even in the UK, there's an estimation that 20% of the households struggle to access good quality food at a reasonable price. So we need alternatives, and there are many ways to get around some of those challenges, and one of them are called alternative proteins. Those alternative proteins can be divided in plant-based, cultivated and fermentation. Plant-based, we see them in the supermarkets, these plant-based burgers or plant-based milk alternatives. They have challenges, mainly in the space of taste and nutrition. They are not quite the same as the products they try to replace. Cultivated meat is creation of food using cells from animals. So you can, in theory, create exactly the same texture and taste, but so far the technology is quite costly and need to decrease costs significantly before entering the market. And the third type of alternative proteins is microbial foods or fermentation. So in the context of this paper, we define microbial foods as any food product or ingredient that is produced via microbial intervention. And that includes the three types of fermentation processes that I'm going to describe in a second. And that takes me to the second part of the report, which is about microbial food, what they are. So there are three types of microbial foods: traditional, biomass, and precision fermentation. All of the three have been around for quite some time, especially traditional fermentation for millennia, but biomass and fermentation have been in the market. We've been eating those products in the 80s and 90s. So it's not a super new thing. What is new is what we can do now with the technologies we have. So the first of them, traditional fermentation, has been around since Mesopotamia times. It's so embedded in our diet that 1/3 of the food we eat has an intervention of a microbe of some sort. And that contributes to preservation, safety, flavors, texture, nutrients, and gut health. On the other hand, we have biomass fermentation. This is when we grow in a fermenter microorganisms, and at the end we recover the microorganisms and we eat that microorganism. So the UK is a very unique place in the world with one of the larger markets or biomass fermentation, thanks to the brand corn that you can find in any supermarket. This is a microorganism called Fusarium venenatum that has very rich in proteins, essential amino acids, etc. The third type is precision fermentation, and this is mostly about using microorganisms that can produce specific ingredients. And sometimes this microorganism has been engineered to produce these compounds in a more efficient way, a more sustainable way. And those ingredients can be any types, can be proteins, can be fats, can be fibers, can be aromas, antioxidants, colorants, etc. And can be purified completely from the process and the organisms and can be used as a food ingredient. So all of this type of fermentation, they have some advantages, and they have in common that they are more sustainable. They use less land and water, they produce less emissions, and they can use feedstocks that are renewable. They can use food waste, they can use even CO2 to grow. They are also considered nutritious and healthy. They usually have a balanced nutrition. They have micronutrients, they have fibers and protein, and they are considered good for our gut. They also contribute to security, food security, in the sense that you can produce them independently of climate, season, or disasters. They have very short process cycles. Some microorganisms duplicate in 10 minutes. And then you can scale them very easily once you have the capacity, right? So let's say we need more food tomorrow for whatever reason. We just put another fermenter, and the day after, we have the double amount of food. That can happen with traditional agriculture, where you need longer processes to create more food. But there are still some challenges, and some of the challenges are cost, quality, and consumer acceptance. So we need to work and create solutions around that. And part of what we do here at Imperial, in the Business Center Microbial Food Hub, is around these solutions, right? One big solution is engineering biology that allow us to make process more efficient, microorganisms better at producing those molecules, so that can make also reduce the cost. They can improve the quality by enriching specific nutrients, etc. Another challenge is that we have scale-up capacity in the UK and in Europe in general is quite reduced, so we need to increase this biomanufacture capacity. And other solutions to these challenges come from regulation and policy. So the third section of the paper is about accepting those microbial food. And there are three main points on it. One is about engaging with the producers and how this microbial food should be produced and where. And integrating fermentation with farmers is very important. They are naturally linked already because to grow microbes you need feedstock. These feedstocks come from agriculture. So farmers will still produce this feedstock for microbes to grow. They also can even have their own fermenters in farms to produce this locally using their own residues from other agricultural products as well. So consumer acceptance is one of the challenges I mentioned before. It's very important, and the way to go about it is by making product that has high quality. They taste great, they have a great texture and appeal. It's important to do marketing about this and tell people about the advantages of these microbial foods. And highlight the health benefits and study more of those health benefits that very often hasn't been completely proven yet. Sustainability is a big aspect for consumer acceptance. So the last surveys say that 70% of consumers in the UK will choose a sustainable product in the supermarket, but the reality is that only 7% buy that sustainable product. And that's basically because the consumer sometimes doesn't know if it's sustainable or not because there's no labels that indicate that. And second, because they're usually more expensive and they don't buy it. And the third aspect on this acceptance part of the report is about regulation and policy. So it's clearly important for food security. So government, the country should be thinking about how this is a solution to this food security issue. Can contribute to job creation, but also job displacement. So there's a consideration that need to be taken as the industry grows. Economic growth can be linked to this, and many reports support creation of jobs, etc., as fermentation develops. And clear regulations or new regulations and labels is important, and we're very happy to see FSA and the government making steps in the right direction in this with the creation of Regulatory Innovation Office, so the recently announced FSA Innovation Hub, which is focused on fermentation, or the NFX project where Imperial is part of, that is funded by Innovate UK as well, which is Novel Food Network. It's also important to think about trade and exports, especially if we think UK can become an entry point to the European market. It can become a nice place to come, do science, create technologies, make companies, manufacture products, and then export them outside. And that leads me to the last part of the report, which is the policy recommendations, probably the most important part. So if you're only going to read one page, read that page. That page has a lot of recommendations, and I don't have time to go through all of them. So I selected my favorite ones to share with you. So in the theme 1, product development, there are two key things. One is we need infrastructure, we need scale-up capacity, and we need to invest on that, and this transition from lab to market. The second is continuing or increasing investment, both public and private, in engineering biology as a key technology to develop microbial food and in microbial food as a whole. And that investment needs to be in the academic settings, but not only, also in industry. The second theme, regulatory context, one thing that I think will help massively the development of the field is including microbes in the precision breeding legislation. Now it only covers plant, but plant cycles, even for research, are very long. In microorganisms, we can develop this much, much faster. So troubleshooting, creating new technologies can be quickly accelerated with that. The second one is streamline regulation and facilitate the approvals of food and food ingredients, so something that will be discussed in this innovation hub I mentioned before. The third theme is demand, and that's, we believe microbial foods should be favored, included in national dietary recommendation, and also public sector catering as an entry market to the general public. And also we should be promoting the acceptance from government from top down by maybe promoting with subsidies to healthy food, or even taxes to non-healthy food, and promoting also with marketing campaigns as well. Just the last 2 slides are about who is behind this report. We mentioned the School of Convergence Science and Sustainability, and in that context, Imperial leads the Microbial Food Hub and the Best Center for Sustainable Protein, which are a big amount of investment that created them last year. They already have more than 100 researchers, becoming one of the biggest networks for research in this area of microbial foods in the world. And more in concrete, you have the information of the authors in the report as well, but I would like to shout out to Richard, Gary, Tilly, Karen, and also the 3 heavy lifters of the work with us, Lucas, Elena, and Shirin as well. With that, I would like to thank you all of you for your attention and enjoy the reading.
Thanks, Rodrigo. We're now going to have some people step up and join me here for a panel discussion to talk about the paper. That means you can also ask questions, Rodrigo, after. Okay, good. So just to introduce the panelists that we have Professor Gary Frost, who is a chair in nutrition and dietetics here at Imperial. So you're going to be able to tell us something about our health and how these affect our health. Then we got Dr. Aphrodite Chatzifranco, who is an associate professor in sustainable bioprocessing at the University of Reading. So you're going to tell us a bit about the research side. I hope. You can talk about anything you want, actually, but these are the... Then we've got Dr. Richard Smith, head of synthetic biology at Better Dairy, leading some innovation on some of these animal-free products. So we look forward to hearing about the challenges from your side as well. And then finally, Dr. Tom Vincent, who works at the Food Standards Agency as a deputy director for innovation and leading the Innovation Hub. So a really nice selection of people here. So we're going to spend a little bit of time having a chat that you're allowed to watch. And then you can gather up your questions and ask them in a moment. So Rodrigo went through in quite a lot of detail some of the reasons why we might need to look for alternative protein sources in the UK for our diets and for what we produce. I'm interested in hearing from you, from your perspective, what do you think the reason is? You know, there were lots of reasons there, so choose your top reason. I'm going to start with you, Gary.
I think I'd broaden it a little bit. I'd say we should be looking at foods rather than just the proteins. So it's microbial foods. So if we take it at that point, I think from my point of view, there are 2 levers. There is the health of a nation, and there's also the environmental factors. And the 2 come together in this conversation. They're very challenging, as Rodrigo pointed out in the actual, the introductory talk there. The actual uptake of microbial or alternative foods it's not rocketing away at the present time. So then that needs to be taken into account if we want to do it. Some of that's about expense, some of that's about taste. So it needs to be unpicked. So, you know, there's clever stuff in a laboratory, but at the end of the day, if you don't get people to embrace it, it's very difficult.
Okay, perfect. Well, we'll get back onto some of the challenges in a moment.
So there's one other thing
on
the health side, which, again, personally is really important, is that most of ill health is in poorer communities. Therefore, if we want to use the actual global nutritional structure, which these products can improve, then they have to be put in a way that the whole population can actually access them in an equitable way. Okay,
great. So there are these drivers, health and environment, but actually, if we're going to take it on for those reasons, we have to make sure that we're actually reaching the people who need our help.
Yeah.
Okay, great. Good. Aphrodite, what are your major drivers?
Perhaps I want to touch a bit upon on sustainability. So we know that we are essentially over-intensifying our current practices in terms of producing nutrients to feed the current nation. And this is something that is on a global scale, even though here in the UK. So we need to get this an opportunity to rethink a bit on how we do things a bit differently, and not only in terms of producing the ingredients, but then from the point of production up to the actual food that is being delivered to the people. there are steps in the way. So after we achieve, let's say, the ingredient that we have produced it, we need to rethink how we deliver that to the consumers. There's quite a lot to unravel in that particular area as well.
Okay, perfect. So potential for sustainability, but we need to be careful about what we're doing
Yes.
to make sure we achieve the sustainability.
Sure.
All right, good. Richard, you're next up.
I'd say a viewpoint from the commercial side is that at the moment there's market conditions and technology that have come together at the right time point, and there's a huge opportunity for growth of the industry at this time point. The UK has a really deep expertise in life sciences, but as a nation we're not great at translating that expertise into successful products and successful commercial companies. So in terms of a factor for economic growth and for growth in this area, I think that's a really important reason why we need to support this industry, because I think it really has potential, particularly in the UK, to thrive.
Okay, yeah, that's great. Well, that's interesting because you were talking a little bit about that we have the right skill set to achieve that. But it was interesting because when you were speaking, Rodrigo, you spoke about how actually we're adopters of this market. So that also makes it a good place to start if you've got some early customers available in the market. Okay, great. So got 3 different reasons here so far: health, sustainability, and food. Tom, you're a bit on a different side, the regulatory side, but where do you see the value in these alternative nutrients?
So I think from our perspective in the regulator as the Food Standards Agency, we're primarily focused on the consumer, but we do know that consumers want increasingly access to more different types of food for various different reasons that others have covered. And so whilst for us food safety is kind of critical, also consumer interest is really important. And so knowing what consumers expect of their food and what other types of food and innovation would support that is quite useful to us when we're regulating. And then when you think about the wider government and the policy agenda, then exactly this around sort of the UK's strength in technologies like this and the opportunity for economic growth and the government's economic growth mission. And that's kind of behind the investment we've seen in the Innovation Hub, for example, is because the government really wants to maximise that option.
So that's a really nice perspective then, like also thinking about it from what people want too, so that consumer angle's great. And then tying up there with what Richard was saying about economic growth. Okay, good. So if we've established now that we have lots of reasons for wanting these things, and you started to touch on this, Aphrodite, how do we do this in a way that actually starts to deliver against those objectives? So what are the factors to consider when we create these alternative nutrients?
I guess one of the things that we have brought us in this moment is the fact that in pockets, people have been working on microbial foods and ingredients for years, even on research-intensive institutes. I think now we are on a stepping stone, and this is why this particular opportunity with Hub and the Bezos Center is bringing together, is bringing all the stakeholders in one place. We need to talk to each other because in pockets we know things and we have advanced our own fields. So from a food perspective, for instance, if we were to translate what we know nowadays in the food, we need to consider aspects that, in terms of nutrition, how these ingredients are being absorbed, if they can actually be implemented within existing infrastructure, or we need to change the infrastructure to accommodate those particular ingredients. So there are things that we don't know yet, to the point that we can tell to people like regulators that, this is by all means ready to go. So I think there is a potential here to work as a team all together from different perspectives so that we can create the landscape so that this particular field can advance in the next decade.
Great, so we're at an inflection point and all the kinds of expertise we have across this table are needed.
I think, yes, there's better now the chance to start communicating and talking to each other, having a common goal of actually transforming the food system.
Okay, perfect. I'm going to turn to you, Richard, then, to say something about what you think factors we need to consider in developing these alternative sources.
I think in the UK there's a big gap. The challenge is really scale up. There's multiple companies that are at startup phase. Getting beyond that valley of death, where you're translating that lab technology into tons of material is incredibly expensive, and often startups struggle to find the capital to be able to scale up and improve their technology. In the UK, there's not a huge amount of resources that are able to provide that service at a reasonable price. So there's other countries in Europe that do have those facilities. if we were to have them and the UK was able to subsidise them in some way, I think that we really could see a lot of those startups that are restricted by that cost get through to actually getting a product into the market.
And just for the benefit of the audience who might not know as much as you know about what scaling up this kind of,
Oh.
what would be a piece of equipment that you need at what kind of size?
I'm sorry,
What are you looking for?
Often in labs, we can grow stuff in flasks, we can grow stuff in 10-litre bioreactors. Once you start to get to 100, 1,000, 10 cubic meter reactors is what you need for kind of a product that's a reasonable cost. That's when it starts to get really expensive. You don't have those facilities in most universities. There's not many facilities in the UK. So that's the kind of scale that you need to demonstrate.
And that would be getting one that you could test, maybe share with other people as a first instance?
Yeah, so you need to demonstrate that your process works at scale. It can work in the lab, but for people to invest and for customers that you're selling to really trust that your product can be made at a reasonable price, you need to demonstrate that that can be transferred. Without that demonstration and also producing material to meet the regulation requirements, you can't get far.
Okay, perfect. That's helpful. So then going back to the health stuff, you know, when you're at the beginning of this journey of creating an alternative nutrient source, what factors would you need to consider? You mentioned distribution.
Well, I mean, in my field, if you take the nutrition side of it, I think ultimately what you're trying to do is you're trying to encourage the UK or a population to consume these products on a very regular basis. So you're putting something into the food chain that is going to have a massive effect on people. And therefore, you've got to make sure, nutritionally, the performance of that product is identical to whatever's being replacing. And that's not just about protein, that's about the other nutrient portfolio that those products actually have. So you need to be, the danger is that we assume things, that we assume that foods behave the same, and they don't. We know that you change the structure of food and you get a different performance. So I think the actual worry is being lazy about this. And I think exactly what you said at the very beginning is really important. We've got, in this kind of environment, we've got a beautiful chance to actually look at the full pipeline. So we can take things from the very start of the laboratory or cell or whatever you want, or the fermentation, and you can follow it all the way through to hopefully producing something that people will want to actually buy off the supermarket shelf and will actually improve their health.
And how would testing a food, I'm just curious, compare to, for example, the development of a drug? So another thing that we ingest. How intensively are you testing and assessing the product in both people as well as in a lab?
Yeah, so you create a pipeline, and that's what we're trying to do. We had a little poster out there on it, so that you actually use quite high throughput in vitro, so lab bench facilities to look at some of the performance. But then you actually, once you've got through that, you then deep dive and you bring in human studies, a lot of which need to be done in great detail.
Great, really interesting. So I guess that takes us nicely onto the, I'm guessing, safety side. So what other considerations as well as health might we need to think about when we're creating these alternatives?
I think when we're talking about factors to take into account early on, you probably want to be thinking quite early on about regulation, even though it's a bit far downstream in the overall process, just because some of the requirements of regulation might frame the sort of trajectory you start on. So, nutrition is a really good example where a novel food to be authorized needs to be nutritionally equivalent to what you're replacing. So you need to be thinking about that as you develop a product, as well as all the things around safety. And there's also, as part of that, not only trying to understand the regulations, but trying to sort of make sure that you're engaging with the regulator early on, so that you can clarify questions, so that we can have discussions. I think that's also quite key for us. A question that I know comes up a lot when we're talking about alternative proteins in particular to some of our students, but it applies maybe to other foods as well. You said that to pass regulation, you have to have the same nutrient value as the thing you're replacing. And we often get the question, well, why are people so keen to have the novel food be like in some way a previous food? Couldn't it be a
mix of nutritional components of a range of previous products and therefore not be comparable or mimic something previously.
Yeah, and that, for us, that's what a business, for example, that puts in an application could argue. So it's up to the applicant to explain what the product is, what it's designed to do in the food chain, and as part of that argument, they may say it's actually a completely new thing and it isn't comparable to this or that, and therefore we're proposing it looks like this.
You were both nodding when I asked that question
Well,
too.
yeah, but I mean, I agree with you. You shouldn't be producing, you know, an identical product to whatever the animal product is at all. But you need to make sure that whatever's going into the food chain delivers exactly what it is that it's actually going to replace. So taking protein, so you have essential amino acids, it's beholden on us to make sure that as that protein is digested, that you get the same portfolio of essential amino acids flowing into the human. And again, you know, proteins are complicated things. They digest very differently. So again, we've got to stand back and say, well, we shouldn't assume, you know, it's beholden on us to test and to make sure that we're actually producing something that will enhance health of people.
That makes sense.
Just to add, from a food manufacturing perspective, sometimes it helps when you have a type of product in mind to look for specific properties. So if you think, for the instance, the example of having a burger patty, which is not meat-based, you would look for specific properties for those ingredients so that we will mimic something that the customers and public are familiar with. And it's better, let's say, in terms of acceptability, have something which is very familiar. Although this particular approach has failed in the past. So, for instance, you cannot really convince a vegan person to eat a sausage because, you know, from ethical reasons, they are just against this type of products. So, yes, there is a scope to rethink how we do. But I can understand why people would probably start from a benchmark product that resembles something that the audience and the public is familiar with.
Yeah, that makes sense. That makes sense to me. Okay, so I want us to go into a bit of the detail of the foods themselves. We've said, okay, we should have these foods because they deliver better sustainability, they deliver better against, or they have the potential to live better against nutrition. So how do they compare? What is the detail of how they compare? And maybe if we start with sustainability.
Well, how they compare? It depends. Well, are we focusing on protein or general? So, for instance, we do have microorganisms who are producing ingredients that we rarely find in nature. So we can have, for instance, oil that must be much more supplemented with polyunsaturated fatty acids, which are very rare to find elsewhere, or different structures. So one thing is the beauty of the ecosystem, that it is a cell factory, a very mini cell factory that can produce things that we wouldn't have it from any other sources very easily. So that's one thing. And then the other thing is that when looking, there is a potential in terms of what we know in terms of sustainability to essentially remove the need for having an extensive footprint to produce the food that we want. So as Rodrigo was saying, we can do this in a reactor. Now, the reactor that we're talking about in terms of commercial application is probably 5 or 6 story high. So it's quite a large vessel.
Bigger than this room? It's taller.
Well, it's certainly taller.
Yes.
But then this is what Richard was alluding to. So when you are increasing on scale, you are multiplying your needs in terms of energy. You are multiplying the needs in terms of processes that they need to be had in order for you to have your ingredient in the end. Apologies, this is not happening. So from that point of view, we need to ensure that whenever we are implementing these particular ingredients or foods, we need to make sure that the steps, so even though the production as such of the ingredient could be more sustainable, we need to ensure that further steps along the line are also sustainable, or at least they're meeting our carbon neutral goals. Because you may have a process to deliver which is very much sustainable, but then your other processes to dry, to make it into food products, to deliver into retailers and consumers could be high in terms of carbon emissions. So we need to strike a balance between these two and not look at it in isolation. So because it's made from microorganisms, it is sustainable.
Yeah, it's not as simple as that.
No, unfortunately.
Because I presume it also goes into what people are replacing.
Or perhaps different types of products. So corn, for instance, they've tried, as an example of a very successful company, because it's mentioned also in the report, so they've tried to put some convenience type of food. So they had ready-to-eat meals, for instance. So it was something that will help people familiarize more with this type of product. It is probably part of your point of view in terms of where you identify a gap in the market and how you launch a product in there. But we wouldn't necessarily need to have a type of food. It could be embedded within anything that we know.
Yeah, okay, great. So then I'm thinking still about how the microbial foods compare to alternatives. Maybe, Richard, you could say a little bit about, maybe with reference to your particular product or your experiences, how they compare.
Yeah, I mean, in terms of sustainability, Better Dairy targeted a product that has a very high carbon emissions associated with, which is cheese. Microbial products are not as sustainable as plant-based products. They're not a primary producer. You use feedstocks, carbon feedstocks. Often you're not using waste feedstocks. So there's often a challenge there if you're going like for like with plant-based foods, that you're probably not going to get a better carbon emission. But compared to animal-based products, which are often very carbon intensive, there are opportunities there. And cheese is a really good example where per kilo the emissions are really high. So having a product, obviously we try and reduce the emissions associated with producing our products, but like for like, there's a big opportunity there to reduce emissions. Yeah, I think I've answered the question.
Okay, good. No, that's great. That's great. So, what do you see in the pipeline? Like, how is the comparison between the microbial foods and other normal foods?
From a regulatory perspective, we don't necessarily take a view on the comparison, but we invite people to explain that comparison to us, because when a novel food, for example, is authorised in the UK, it's a minister, it's a politician who will authorise it, and we provide the advice. So we don't just talk about safety when we give that advice, we also talk about any other factor that a minister might care about, and so that could include sustainability, it could include food security. So knowing more information about the product beyond just the safety case is really helpful, and that comparison is part of it.
Okay, interesting. Interesting to know. It's high-level sign-off. I mean, it's a big thing to introduce a new food into the market, so I can understand that. So let's go to the health side. How do the microbial foods compare on the health?
We don't know.
You don't? Okay.
At the present time. So the little bit that has been, Corn were are an exceptional company. They did an awful lot of work, very short-term work, to try and demonstrate what impact their products have on health. And most of those studies, although they were done under short periods of time, actually show some degree of positive outcome. So that if you replace something in your diet with the equivalent of corn, then you see drifting down of markers like cholesterol, for example. I think there is a question mark at the moment, but here's a chance to design something to fill in some of the gaps that we've got currently in health. So one of them that was picked up before, not just about protein, is about dietary fibre. Dietary fibre is a massive issue. The UK population hasn't changed its intake for the last 20 years. Here you can design something that could actually potentially taste wonderful and deliver a bunch of dietary fibre to the population, and that will increase health. But it remains to be seen. The potential is enormous. It's absolutely enormous.
That seems kind of exciting. So
yeah, it is. It's very exciting.
And you know, some of the
But you've got to get people to eat it.
Yeah, I mean, you can't even have a child and no one's eating.
That is don't underestimate that, because changing what people eat or perceive is very difficult. It's enormously difficult.
Well, then let's go into challenges.
Yes.
We're on challenges.
That's wonderful. Yeah. And this is the wonder of the centre, because you've got the gastronomy there as well. So you've got that pipeline. You've got people that actually will be able to design foods that people want to eat.
Yeah. Well, I mean, I think you already made this point, Aphrodite, that also even starting with a comparable food that people recognise, or a ready meal, or a use or cheese, something that people recognise as an easier way to get people to even think about adopting it, rather than something
to begin with, yes.
To begin with. All right, what other challenges, or you can comment on that challenge, do you see?
Price, I'd
Price.
say.
Yeah.
So it is quite challenging at this moment to make something of that scale. Sometimes these ingredients are specialty ingredients, and then make a product that it's equivalent and affordable to the general public. And we need to think that, I think one of the key challenges of our current food systems is that there's still food insecurity. So if we're trying to transform that, we need to ensure that it has a wider reach. And price is not a limiting factor for an otherwise very healthy product.
And at the moment, is the price determined by, we've got high electricity prices, or that it's not at scale yet? Or do you foresee that once it's at this larger scale, the price will go down?
I think it's a little bit of everything, and perhaps the companies can tell you a bit more about that. But I think obviously we don't have enough of them, so they are considered still a very niche product on the market. It is likely, as we say with other products, once there is much of a take-up and there is much more opportunity for scalability, obviously the prices are going to be perhaps a bit limited, but then you have a challenge of feedstock. So there have been probably in the 70s or 80s attempts to scale up microbially produced ingredients in the past, and they have failed only because of the price of the feedstock.
Right, which are kind of volatile and also high.
Exactly, exactly.
So I guess this is your area of expertise, Richard?
Well, I'm a synthetic biologist, so not really, but yeah, I'd agree. There's the cost of the feedstock, there's the huge capex cost of the facilities you need or need to hire. There's huge losses with the downstream processing. So all of this adds up to cost. And you're competing against an industry that's very low value. Like the margins on food products are very small. So it's a challenging industry to get your costs down to compete. But we have opportunities to have higher value functional products that can replace high value functional products in the food industry. And that's probably the best first step into the market, is to replace those specialist ingredients first, and then go into a broader lower value chain once the technology has matured.
And are we talking about it being better? I mean, go back to a combination of cost and public perception to make microbial foods a standalone product, like we see with the kind of new burger, et cetera, or corn itself is now a product people recognize, or to hide it in other things, so that it can be replacing some other protein you don't see or nutrient that you don't see?
I guess from a technological point of view, when we're talking about microbial biomass or precision fermentation, it's very difficult to make a food directly out of the reactor. So you need to bring other elements as well to provide texture, possibly, much more of a color appeal and so on. So it would be difficult to have it as a standalone as it is. It's much more of a traditional fermentation when after fermentation completes, the product in the end is what you consume. So I wouldn't say hide it. On the contrary, I would say actually make noise about it, because there is a good reason why this should be there. So either from a nutritional point of view, or because we want to diversify our nutrient sources, or because we need to contribute to sustainability. So
maybe hide it's the wrong language. So maybe use it as an ingredient that you talk about.
Yes,
I
think that especially when it comes into precision fermentation products. So for instance, making proteins that are used to be dairy from non-dairy alternatives or from non-animals, they will be ingredients that form a product in the end. So certainly there's a chance there. Vitamins as well, oils, we had talks about fats earlier on. So there are quite a lot of ingredients that we could potentially create in a different way.
Okay, perfect. So going back to challenges, some people might say that the regulator is a challenge, or there are challenges in regulation. You earlier said people should think about regulation earlier, but how do you see the challenges?
I think there are definitely challenges. I think one of the key things is understanding the regulation in the first place, especially when you're a startup, for example. And so there's sort of an onus on us as a regulator as well to be excessively communicating what is required in law. There is then, for us, quite a lot of complex questions around how you apply the current law to completely new products that maybe weren't even conceptualized when the law was written. And that's often through, for example, coming up with new guidance, and we have to sort of work with industry to understand what's needed on that. Then on the science side, there's the safety sort of hazards and additional safety considerations you have with entirely new processes, and how you understand what they are. And these are all the kinds of questions we're looking to use the Innovation Hub to start answering for microbial foods. And then I think going back to the point on scale up, I think the other challenge we hear from businesses is, great if I get this authorized, this product, but if I scale it up and it changes through the nature of the way I've scaled it up, can I still sell it? And so that's, again, a question where we have to be a lot clearer what you can and can't do with an authorization from the regulator.
Okay, very interesting. And this innovation hub that you're part of, is that for a wide range of products or particularly for food
So
products?
the Innovation Hub covers all novel foods and all foods created through genetic technology, like gene editing, for example. And then the additional investment we've recently got is going to really focus on precision fermentation.
Okay, great, interesting. Okay, in the last few minutes before we open up to questions, I'd like to hear from each of you what you think the next kind of changes or actions are that could help take this area of novel nutrients and microbial foods forward, and your role, what you're going to be doing. So it sounded like new trials, Gary, or?
I think it's creating a rapid pipeline that will allow products to flow to the regulators very rapidly. I think we're in a position where we can now do that. We can actually start to think about how we network, certain laboratories within the UK to actually ensure that products are tested nutritionally very rapidly. So I think that is, to my mind, that's probably the most important thing. And we look at things broader than just, the breakdown of a certain nutrient, that these foods can have other effects on the human body, such as inflammatory responses, that we can actually start to unpick.
Okay, great. So that's, again, the power of working together.
Absolutely. Yeah. And that's the beauty of the start of this, is the actual power, the shift. It's a seismic shift to have this true multidisciplinary working. And
what would you say, just to give us a feel, the time frame for that, let's say, for a product being tested before you could hand it over to Tom?
Well, let's wait and see. I mean, I think we should be, at the moment, I can give you an example of one thing that we've had that was a disaster. So we've had something in the pipeline going through regulatory systems for the last 10 years. And we need to shrink that substantially. So we need to actually bring that down. I think you should be looking to try and get things through in a reasonable amount of time. So, 2, 3, 4, 5 years, I think, from the product actually hitting an environment where it can be given to a human.
Okay, perfect, great. I'm going to jump around a little bit. So, Tom, what do you think the next things we need to do are?
I think for us, it's kind of twofold. It's first of all understanding more about what consumers expect and want. We do quite a lot of consumer research, for example, on whether consumers would want to eat this and what they would expect to see in terms of labelling, for example. And that all factors into then our policy approach. And then the second area is then collaborating with industry and with academia to talk about the challenges there are of regulation and work out the way forward.
Great, perfect, very constructive. Richard.
Yeah, I'm going to say a very similar answer. I think collaboration is definitely what we need, particularly making sure that we know where the expertise is and can access it. I think there's also potential of access to. There's so much equipment within academia that's kind of unused that could be used for having collaborations and networks where we can see where the expertise, where the equipment is, really could start to unlock some of the frustrations we see in industry in terms of we can't do this because we've only got a certain amount of money. So hopefully we'll see that in the next few steps with groups like this.
Okay, brilliant, great, thanks. And Aphrodite.
Well, from a food science perspective, obviously, we are in the process that we need to, collaborating with engineering biologists, so the various strains that they have been developed over the years, and they see that they have potential. So now we have a chance to see actually how these ingredients function within a food matrix, and of course support new startups and companies in that area that they have a know-how at the moment, but they want this crucial next step to scale up a bit and see how this particular ingredient could work within a much more, let's say, relevant environment of a food manufacturing. So we are supporting, I think both sides and both ends, and at the same time educating the new workforce. for the future on a challenging food system.
I mean, I think that the other thing is science is changing, and you can bring in consumers in at a very, very early stage and understanding exactly what they're challenged with and what their opinions are helps enormously.
So a much more integrated approach to research in this area, where you're bringing in kind of research subjects, but as an engaged part of the process.
It's doing things in partnership with the population, not doing things to them.
Yeah, with them, not to them.
Yeah.
All right, great. Well, that all sounds very exciting. Okay, so it's time to hear from people in the room. Hopefully that's provoked some questions in the audience. So we've got a microphone over here. All right, good, lots of questions. If we can start with the lady there in the middle, sorry. And then we're going to come across on the same row to the gentleman at the end of the row.
Thank you. My question is actually related to the last point being made, so that's good. It was about the strategies for kind of consumer interest, let alone acceptance, but because, people say they like sustainability, but as Rodrigo mentioned, that doesn't necessarily translate as buying, and what would be the effective strategies for that? Thank you.
Okay.
Yeah. So I think having people as partners from the very outset of the research becomes critically important. And now, the way that things are networked together, you can do that at scale. So you can go out to large parts of the population now and say, hey, we're doing this. What's the opinion? And you can get really, really valuable feedback. This isn't new. As Rodrigo said, they've been around for a long time, but it's never taken off. So there's something about unblocking that, which is really important.
And Richard, so we do these kind of studies, but as a business, what work do you do to understand the consumer and how they really going to interact with your product?
I think the main factors for consumers is the price and the functionality of the taste. When you think about if you've experimented with a different product, you might go back to it, or you wouldn't go back to it if it was inferior to the product that you're trying to replace. And if it's too expensive, then you're not going to go back. It might just be a treat. I think there's a potential with new products coming in the market and fusion of plant-based products with microbial products to really develop upon the shortcomings of plant-based food and at a lower price point. So I think those two factors are the main ones that we should focus on.
Okay, perfect. Great. We have more questions in that row. Okay, and then you can just pass it on to the gentleman at the end after.
Yeah, okay. Thank you. So my question will be about more about cultured meat because of the personal curiosity. So I wanted to ask what are the main bottlenecks in gaining regulatory approval for cultured meat in the UK, and how close are they to seeing actual commercial products?
I think that question's for you.
Yeah. Well, as you might be aware, we've recently launched a regulatory sandbox on cultivated products, including cultivated meat. And the aim of that is when you have something as innovative as cultivated meat, you have a lot of unanswered questions, both about the safety and the science, but also about the law and how that would apply. And so what we're doing with that program is basically working together with industry and academia to go through those questions and work out, well, what do we think the answers should be? And then from a regulator's perspective, say, if we're going to regulate it in this way, what are the impacts for you? Help us understand them so we can make sure that when we do come to decisions, we're doing that in the full knowledge of the impact on the industry and what that means for what the regulations will say. So I think the biggest barriers we're finding, for example, with cultivated meat, for example, you've got a question different to microbial foods, which is obviously it's coming from normally an animal origin because it's normally an animal cell. So does that mean cultivated meat is a product of animal origin? Is it meat? So that's a really fundamental question because food law is designed, it was designed many, many decades ago, but there was a lot of regulation around those products, for example. And so that's exactly the kind of question that means it takes time to understand exactly how long, how we're going to regulate this thing. But that's exactly the kind of thing we're testing. And so hopefully through that program, we're going to radically reduce the time it takes to come to answers on those questions.
And just for clarity, for people who might not know, could you just explain what a regulatory sandbox is?
Yes.
That maybe sounds more fun than it is.
I wouldn't want to comment. Basically, it means, in our case, it means taking a more innovative approach to working through regulation. So ordinarily what would happen is a company would put in an application to us and we would assess it. We might go back to that company and ask them questions about it, and that's how the process works. In this case, we're getting ahead of the curve and we're working with industry in advance to say, okay, what, across the industry, what kind of clarity is needed to even put in an application, for example. So to have those conversations before industry or before a company has even come to the regulator with their own product, ask, well, what's holding you back? What are the questions you need answers to even get to that stage?
Right, so anticipating then a flood of applications from Gary's pipeline. That's good. Okay, great, and to the end of that row.
Thanks, Tim Spector. Two questions. One for Tom is, so if we weren't part of EFSA, would this be a lot easier to manage and we get our own rules and regulations, a bit like Switzerland, and we could streamline all this and Gary wouldn't be waiting 10 years to get his product to market? That's question one.
Well, could you ask both your questions and then we can...
Okay. The other one was, other countries are more flexible in their regulations. The US, Singapore, Israel, they have lots of products in the market. Some of them are commercially successful. I'm talking about things like egg white and some milks and other dairy products. Is that going to impact this country? You know, do you think they'll ever be imported and that will change public opinion as people see that other countries have taken to this anyway, while we're still fighting through, you know, what we're defining as the food, others are actually using it? Will that have a big impact? So there's sort of this other, you know, because we never talk about other things that have been out there for years, like rennet. 95% of all cheeses have, you know, microbially produced rennet in them. That is accepted by the public, it's accepted by the regulators. We never talk about it. So why would some other protein being added to something as a dairy substitute or an animal substitute be quite so controversial when we have these great examples?
Okay, brilliant, thank you. A couple of questions.
Great questions. I think on the first point, just to clarify, we're no longer part of EFSA. Since we left the EU, the FSA now runs the regulation in the UK. So although we've inherited quite a few things from EFSA, because we're following a very similar regulatory framework, we do now set our own standards. And what we've done with that since leaving the EU is we've started with some overall reforms, so not specific ones for novel foods, but we recently passed new legislation that has removed the need for companies to apply for renewals in certain circumstances for authorizations, like gets rid of bureaucracy for companies. We have also overhauled the process for giving effect to an authorization, which is basically the administration that follows our safety work, and removed and streamlined that whole process to reduce the time it takes to do that by up to 3 to 6 months. So those are reforms we've recently introduced through legislation that have taken advantage of the fact we're no longer part of the EU system. And then when it comes to sort of trust in these products, I think the first thing I would say is that the food safety culture in the UK is quite different to some other countries, and we know that consumers trust what the FSA does, and as a result, when an authorization is provided for a product, that gives that company the credibility of that seal of approval. And that's because we have robust regulations, and it's because consumers want to see that. And so what we know from our consumer research is that although there are a large proportion of people who, for these innovative products, they don't know what they are, so they don't really have an opinion, there are quite significant amounts often that say they don't think it's safe just by hearing the name of the product. And so we do have to reassure consumers that they have been through some kind of assessment to help them on that journey if these products want to be sold.
Okay, perfect, great. And there were other hands that weren't in that row up there.
Chris Wadrup from CPI, a statement and a question, if that's all right. Totally get you, Richard, in terms of scale up and cost of scale up in the UK. CPI is opening a 400-litre fermenter at food grade standards at the end of this month, and we've got the Novel Food Innovation Labs, which will help have a conversation with the team there when costs are a challenge, and it's about what can be afforded as opposed to what would the gold-plated cost be. So that's something if people want to go and use it. And outside, a number of people talked about feedstocks and using waste food. So a question to Tom, how do you regulate or manage the conflict between the waste sector and when does end of waste apply, or when did start of waste apply to waste food for people to then use as a feedstock for a food grade product? Because that circle doesn't connect.
Okay, perfect. So stop Tom having to field all the questions. I'm going to send a version of some of the questions down this end, but I'm going to come back to you in the end. So this idea of using waste for food products, I'm interested in understanding a little bit if there are health or sustainability implications there.
I can help a bit to start the discussion.
Perfect.
So I think there is confusion in terms of terminology, what is considered waste and what is considered a byproduct. So obviously, by regulation, a waste is something that has contaminants, so it's not safe to be used for human consumption. Why would you use it to grow microorganisms that are intended for food? So byproducts, on the other hand, and I think Rodrigo mentioned the fact that you must have much more localized farmers and bioreactors sitting side by side. So if you have a byproduct that it is in a perfectly good and edible use, you may as well use it as a feedstock. So assuming, as an example, you are pressing apples for juice, you're making a pulp. That pulp, if you use it within the space of a couple of hours, is food grade. If you leave it for a day, of course, it will go off. So that's not a good use. So I think trying to bring down the costs of feedstocks, we could potentially think about using those side streams, which are food grade still, as a way for our microorganisms to grow on. I think that's the key point there.
Great, perfect. Did you want to say anything about it? Or she covered?
No, that covers it.
Okay,
well.
go ahead.
Yeah.
Perfect, good. Question over there.
Hi, yeah, super interesting. Couple of questions, I guess, or maybe a statement. Something worth teasing out is that unlike many manufacturing sectors in this country, we still have quite a big food manufacturing sector. So I guess at what stage do you involve the food manufacturing sector, recognising there's probably pros and cons to doing that? And then the second one, just maybe a comment on regulation. Sorry to harp on about regulation. As someone who doesn't know anything about this subject, is there, if the regulator's dealing with Imperial College, is that a better thing than dealing with a start-up that's necessarily small and of limited resource? So can Imperial College bring something to bear, or the Bezos Centre, when it comes to regulation?
Okay, perfect. Well, I'll start with Richard talking about working with food manufacturers. Obviously, you're aspiring to be a food manufacturer yourself,
Yeah.
but it is quite an established sector in the UK. So,
Yeah, I mean, there's definitely huge potential for working with manufacturers. An example is the beer fermentation industry. There's huge capacity there that is often underused, and they are interested in using this technology to try and maximise their facility usage. So definitely in terms of fermentation, better dairy strategy is to produce a cheese process, which is a drop into other cheese manufacturing processes. So we fully intend to use the manufacturing facilities that are already available and design our processes to slot into what's already there.
okay, that's great. I mean, any thoughts from your side about working with large food manufacturers? Do you do that in your activities?
We do. Well, I mean, from our point of view, at least at Reading, we see a slow uptake at the moment. So although there is a general interest, because I think they understand that there is a direction of travel towards that area, they are not really fully committed to using those ingredients on a larger scale until possibly they've seen in reality and in action functionality, sustainability, whatever angle from a strategic point of view they want to see. So definitely there is an interest, but it is a bit of a slow interest. So we have discussions on very early stages at the moment.
Okay, great. So, and then, oh yes.
Sorry, I have to say another factor that's quite important to the food industry is security of supply, and there's a hesitation of taking on a new product when you're the only business in town. You could go bust and suddenly they've got a product that they can't actually produce. So having lots of different companies making similar products is great for supporting the industry.
Okay, that's interesting, and then maybe that leads really nicely into answering the second part of the question, which was, could people come and apply to you as a group, or the Bezos Centre as a hub start working through regulatory situations with you before products come?
Yeah, I think both are important. So we do a lot of direct engagement with businesses who have got an application in with us that needs assessment. But we're also looking to use things like the Bezos Centre and various other partners, NGOs, trade bodies, as conduits to get to the wider industry. So we're doing that in that regulatory sandbox I mentioned. That's explicitly part of what we're doing there. And we're also a part of the Novel Foods Network that Rodrigo mentioned in the presentation and want to be a sort of active member of that community. And again, use that as a way to reach companies that maybe we can't reach one-to-one, because obviously we can't talk to everyone all the time. So yeah, it's really important to us, and it's something we're already doing for quite a lot of areas.
Brilliant, perfect. More questions? Are there any questions online? Yeah, perfect.
Shall I go first? Thank you. So I've got a question about science diplomacy. I mean, I get that the centre's about the UK and the regulatory bit must be national, but are there conversations happening internationally to think about the norms and standards, given the drivers that Rodrigo described at the beginning are so global, and the challenges are global, and the scale and investment that's required must go beyond the UK?
Great, perfect. And I'm going to ask you to ask your question as well, just so that we can...
Thanks very much for the very insightful discussion. So my question is related to the microbial toxin. So basically, you know, take a microbial protein as example, often the secondary metabolites could be triggered, and essentially could lead to potential, you know, microbial toxin. And well, it's very nice to see the, you know, FSA basically have this innovation hub to look at the alternative protein, but also as a novel food in general. How would be the, you know, like from FSA, sorry, pointing you on the spot again, and, you know, how is your view to say like maybe moving, like a test out to understand, you know, like the potential toxic and safety side of the novel food and accelerate essentially the regulatory approval process, because the in vivo and in vitro could lead to a very long kind of, you know, like approval process. Of course, in silico approach, essentially, I mean, you can reduce, well, 3R can reduce animal use in your food safety side. However, you know, like, how would you actually balance this in vivo, in vitro, and in silico approach for this novel food? So that's the question.
Perfect,
Thank
great.
you.
So two quite different questions. We're going to have food diplomacy and toxins and how we manage them. So maybe you can talk a bit about the international side, Richard?
Yeah.
Or how do you see your marketplace in relation to the international side?
So definitely we're looking at different markets with different regulations, and part of that calculation is the market size. We're obviously looking at markets that are larger than the UK and have more favourable regulation than the UK. Hopefully, once you're have got approval in one country, it's easier to get approval in other countries, and that does normally follow. If you get approval in the US, that does seem to be easier to get approval in other countries. And hopefully, in the future, other countries will start to move along and see that the risks involved in these products is relatively low when they are approved. Yeah, to kind of follow the lead of the countries that have got less restrictive regulation. I don't know if that fully answers your question.
I mean, Gary, you spoke before about the importance that these foods be available to as many people as possible, considering in the UK food inequalities, but obviously we have health and food inequalities globally.
Absolutely. And again, there's a chance here to try and contribute to low-cost food, high-quality food products for areas where it's challenging to work. So I think the adapting systems to meet the needs to try and wipe out food insecurity would be a massive step forward.
Okay, great, perfect. And then let's go into toxins. Comments about that from your side?
So I think that sort of points to me two things. One is every single product is assessed case by case, and that's why it's important to do that, because of this exact thing. Each product is going to be different, and the different safety considerations you will have will be quite different. What we say to companies is basically the company needs to prove something safe. So if you can justify the type of tests you're using and you have data to support it, then present that case, and we will assess that case. So we're not prescriptive in how we expect things to be done. We just expect people to be able to explain how their product is safe. But then we combine that where there are cross-cutting things like issues that would apply to multiple products, that we have clear guidance, especially on safety-related things. So for example, on cell-conservated products, there are sort of publications out there from the Food Standards Agency that talk about the types of hazards that those products might pose and what they would mean in terms of food safety. So it's a combination of those two things, a sort of case-by-case assessment and then guidance across a food product class.
Okay, perfect, great. A final chance for one more question, if anyone. Yeah, it's the front.
Thank you very much to all of you. I had a very general question. It's just more about the role of AI, particularly in dealing with the challenge of this idea that you mentioned specifically of accelerating the process so that we can get high nutritional value microbial foods to the general public, which is the ultimate objective. I was wondering how you work with the AI or the future that you see in it, or machine learning even.
Great, perfect. AI question. I'm going to take each of you an answer to AI. How are you using AI in regulation?
It's a really good question. So we're trying to actively consider it. It depends on what stage. So we wouldn't, obviously, quite a lot of what we do is very complex and technical, and you'd want a human expert to be doing it and not AI. But there are parts of our service, for example, where you could imagine AI being quite helpful. So, for example, a chatbot that tells you how regulation actually applies to your product. So that's not something we're actively pursuing right now, but there's the conversations happening, which is there's clearly opportunities here to make the service we provide to businesses much clearer. And where we can use AI in that, we will. And you'll see from a lot of the government narrative at the moment, there's quite a lot of push across wider government to incorporate AI into what we do to provide a service to either the public or business, which we're thinking through.
Great, interesting. Richard?
I'd say we do use AI in some elements of our business, but we are a small business, and having some AI expertise would be fantastic, but we don't. So in theory, as the AI becomes a bit more advanced, it would be great for finding best routes for knocking in and out genes to improve that protein titer in our case. At the moment, based on my understanding of the tools, we need to do an experimental approach because there's so much that isn't known about, for example, the secretion pathway and how different proteins follow different secretion pathways, have different levers. I'm not sure whether there's knowledge. There's enough knowledge in the world already for that AI tool to use. So, yeah, at the moment, probably not enough, but hopefully in the future.
I will answer your question there indirectly. So obviously this particular sector hasn't matured enough yet. So if you're looking into other sectors in the food industry that have matured already, AI is used on multiple occasions. So you use machine learning, you use digital twins to be able to mimic and replicate an alternative process without actually having a costly big-scale process, so that you can essentially get some data in terms of if you were to change a process, a particular ingredient, how that would affect your whole production. So in that sense, from a manufacturing and probably sustainability point of view, an assessment of that, when the technology matures a bit better and we have refined which are the win-win situations, I think AI will be used as a predictive way so that we can essentially have duplicate scenarios before we completely perfect a product. So there is quite a scope there as well.
Great.
On that front.
Two things. One is that there is very little known at the present time about where food goes to start with, which is your gut, and how the enzymes work together to break down that at the moment. There's very little information. We're fortunate to be able to do those experiments, and one of the applications we hope to use AI for is to do machine learning on that to see whether there's commonality, and we can build in silico methodology to actually understand how food is handled within the GI tract as far as this, and that will, again, help speed things up. The other one, I don't know if you were here when Monica was actually talking about what we do. The other bit of AI, and again, it's very, very, people often think it's low tech, we don't really understand what people eat at home. Got no clue, because people don't tell you, really. They don't want to tell you. It's very private and personal. There's good reasons for it. So one of the ways that we're using AI is with those small micro cameras, which are two-dimensional, but the AI algorithms that have been written for them turn that picture into a three-dimensional volume, so we can estimate truly what people are actually having in the home environment. So when someone says, well, I love microbial foods, if they take that camera and they wear it for a little while and there's nothing there, then we can actually see that. So it's kind of not directly, but it's really important because, you know, getting at understanding how these foods fit into people's lifestyles on a daily basis is very important. Yeah.
Brilliant. Well, thank you. We're out of time for questions, but there will be a chance later on for you to want to grab one of the speakers, ask one of them a question over drinks. Thank you so much, Gary, Aphrodite, Richard, and Tom, for being our panelists today. That was really fantastic.
Thank you. Thank you.
The authors of the briefing paper, who Rodrigo also called out, and I saw one of them leave before she got thanked, but thanks to Lucas Copens, Shirin Bamazi, Gary Frost, Karen Polizzi, Tilly Collins, Richard Carmichael, Rodrigo, Elena Coruju-Simon, and also to the speakers earlier this evening. Some of you may have missed that, but there were some great speakers earlier today who were wonderful. Alyssa Graham, Alistair McGuinness, Ben William, Christopher Reynolds, Monica Hill, and Cynthia Clem. Thank you to the AV team and to other people who made the evening happen, particularly Leah Adamson, who's also not here because she's preparing the drinks outside and has made a huge effort to make this whole event happen so smoothly. And all that you've got left to do is go back to the reception where you came in and enjoy some drinks and conversation. So thank you.